The first speaker today is Eleanor O'Keefe, who is from KBR and the Air Force. Eleanor, over to you. Thank you very much.
All right, thank you so much. So today I'm going to be talking about vision tests and simulated remote vision system air refueling performance. So I'm contracted to the US Air Force, and we're exploring updates to vision tests because, well, first of all, any views expressed here don't reflect official government policy, nor reflect views of the Air Force, DoD, or the US government. So we're exploring updated vision tests because there has been a huge increase in the availability of display technology, a huge boom since World War II. And so the example I'm showing you on screen is our boom operator upgrade. So on the left, you see the boom operator looking out the window out of the back of an aircraft. And they would either sit there or lay down, look out the window, and use joysticks in order to refuel tankers in the air. But in the new KC-46 refueling tanker, now, as you can see on the right, the boom operators actually have been moved to the front of the aircraft. They're still facing the rear, but they now view the action going on behind the plane through a remote vision system. However, screening technology in order to pass anyone coming into the Air Force to become a boom operator has not been updated much since World War II. So on screen, you can see the Air Force Vision Tester or OPTEC machine. And basically only the casing has been upgraded. The tests do remain the same. So one of our lab taskers, I'm part of the operational based vision assessment lab at Wright-Patterson Air Force Base. And one of our taskers is to see, do the current vision tests actually predict performance with these new upgrades to technology? So we specifically looked at this RVS refueling performance, and we looked at their Air Force Vision Tester. So you can see the stereo test example in the bottom. And we looked at the Titmus booklet as well as our new computer-based vision tests. And I will go through all of these different tests in a minute. So just a quick background. Visual metrics and performance. Of course, poor performance on vision tests has been associated with poor performance on 3D tasks. This has been 3D in general, not just remote vision systems. And then overall, the vision tests that are associated with performance have been those that show binocular vision status, and such as fusion range, stereo acuity. And those have been the tests that are the most important for 3D performance. Then looking at visual fatigue or discomfort, what tests have been shown to be correlated with this? Again, it has been shown that those who perform worse on vision tests report more discomfort. And then again, these are tests that have to do with binocular vision status. So some examples I have on here are phoria, fusion range, and fusional response time. So you'd think that would just clear it up. But other authors have found that there is actually no relationship between viewing discomfort and visual capabilities. So similar tests here, fusion range, stereo acuity. And lastly, still other authors have found that those who perform better on vision tests actually report more discomfort when doing a 3D task. Again, these are binocular vision tests as well as visual acuity. So when doing our research, we expect those who perform better on the vision tests to perform better. But as far as discomfort goes, who knows? So the purpose of this study, again, to assess the relationship between the vision metrics and performance on an RVS task. So we looked at our lab-developed automated vision test battery, which has several metrics, which I'll go over. The Armed Forces Vision Tester, we looked at stereo, acuity, and phoria. And then again, the Titmus. This is just a demographic slide. So we did use boom operators as well as participants just from our local area. Okay. So our remote vision system apparatus, you can see in the right, was actually developed with the help of boom operators. So our viewing distance and the distances of all the screens and the seat and everything is representative of that on the actual KC-46. Our 3D image generator is on loan from Flight Safety, and we had 2 channels for the 3D imagery, again, simulating what is in the actual KC-46, which is a spatially interlaced, circularly polarized display. And this was on loan by Boeing, actually a slightly damaged one that was from one of the aircraft, but it works fine for us. And then we had our 2D panoramic monitors at the top, which just give the boom operator a larger view of what's going on behind the aircraft. I can't go into too many details about the RVS image space. A lot of that is still proprietary, but I can show you a little bit of our simulation. So we did our best to simulate exactly what's on the aircraft. The virtual cameras are towed in and converge to the aircraft refueling distance. They're also separated greater than the average human IPD, so you get your hyper stereo, which is limited a little bit by the fact that the field of view of the display is less than that of the cameras. But basically, the whole setup of the RVS introduces some errors into the image space, which include divergence or vertical misalignment, as well as depth compression and depth plane curvature. Okay, so for our refueling task, which was our performance, our RVS task, was a simulated refueling task where the participant had to make a successful connection with an aircraft. And so basically they used their joysticks to move the boom into the aircraft receptacle. And then once they had a successful connection, they were looking for 3 things. 1, for the actual fuel to tick up to the planned amount. 2, if the aircraft moved outside of the contact envelope, and 3 for fuel spray. So if any of these occurred, they just disconnected. The receiver aircraft flew off, and then a new aircraft flew in. There was also an aspect angle task, which we didn't analyze the data, and participants just had to indicate which way an aircraft was banking. And this just served to recreate the visual demands of switching back and forth between the 2D and 3D displays, which they still had the 3D glasses on to do that. But that's something that the booms have to do in the actual refueling environment. Going over all the vision tests. First, I'll talk about our in-house automated vision test battery, which all of the tests use the psi thresholding procedure. We have our acuity and contrast sensitivity tests, which both use the Landolt-C stimulus, you can see in the bottom right, and the participant just has to indicate the direction of the gap in the C. Our stereo acuity tests, we have 2, one given at 2 distances, which is the dual ring stereo test at the top, just 2 concentric rings. And the participant has to indicate whether they see the inner ring as closer or farther than the outer ring. And then our newly developed stereo search test. The stimulus is the bottom left of the 3 figures. And so you have 3 rings, 2 are in plane, 1 is crossed and 1 is uncrossed disparity, and the participant just has to indicate which ring appears closest. And then lastly, we have our fusion range and motion perception tests. So fusion range the participant just fuses 2 rings. They move from low to high disparity, and then the participant indicates when they can no longer fuse them, and then the rings move from high to low disparity, and the participant indicates when they can refuse them. So this was done horizontally and vertically. And then our motion perception tests are just varied moving dots, and the proportion of coherent dots is varied. So we have a rotational test and a radial test. Participants got all of these. The Armed Forces Vision tests we gave were these stereo acuity and horizontal and vertical phoria tests. The stereo acuity I showed you guys earlier, you just saw rows of 5 rings, and the participant just has to say which one appears closest in each row. And then horizontal and vertical phoria tests are shown on the right. So horizontal, they're shown the arrow in one eye, the row of dots in the other, and they have to indicate where the arrow is pointing. Vertical is the same idea, but staircase and then a dashed line. And then again, we gave the Titmus. We just put the Titmus booklet stereo test on the computer monitor and reconfigured the disparities for a meter viewing distance, since that was close to where the boom operators sit from the screen. All right, lastly, the survey. It was just a 7-item questionnaire that looked at visual fatigue and eye strain based on work by Shibata and then the NASA TLX as well. So we looked at eye tiredness, comfort, adjustment, eye adjustment, double vision, headache, eye strain, things like that. Okay, study design. First couple days, all the vision tests were given. Third day, our non-boom participants did their practice session. And then days 4 and 5 were when we did the actual experimental task. Here's where we give the Titmus. That was a later add-on, so that's why most participants had done days 1 and 2. The horizontal and vertical fusion range tasks, as well as the stereo search test, they were given before and after our experimental block to see if having the participants interact with the 3D display caused any changes in those tests. And the actual experimental block of using our the 3D display was that aspect angle task, the air refueling task, and then the survey. And participants repeated this 8 times. So they were in here in the room on days 4 and 5 for 3 hours. And day 4 and 5 were just a repetition. On to the results. So on the left is all of the different vision measures that we gave. And then on the top is all of our different air refueling task measure outputs. We use Pearson's correlation at p is less than 0.01. And as you can see, the only significant measures were from our lab developed automated vision test battery. And they correlated best with contacts, collisions, and overall air refueling performance. These were our stereo tests as well as our horizontal fusion test. Looking at our vision tests changing before and after using the 3D screen, we didn't see any difference besides in the vertical fusion test. However, that did have a small effect size. And then looking at strain and fatigue as correlated with our vision measures, here we used Spearman's. We did get correlations. Again, they were only with our automated vision test battery. Those had our a couple of our stereo acuity tests, contrast sensitivity, and just regular visual acuity. Okay, so what does that all mean? No AFVT vision metrics were associated with this air refueling performance. One issue here is that in the stereo acuity task, the highest disparity is 40 arc seconds, and so we had to leave 8 participants out as they couldn't detect this disparity. So in the future, any participant who can't detect the highest disparity, we plan on giving them the AO vectograph, which is what the Air Force does. The Titmus was not associated, but but our in-house AVT stereo acuity and horizontal fusion tests were correlated in the sense that the better you performed on those tests, the better you performed in the remote vision system task. All right, eye strain and fatigue were the same, just our AVT tests were correlated. However, this actually disagreed with some previous tests in our lab, and just agreed with those who showed that those with better vision had more discomfort. So that was somewhat unexpected, but we have had problems with subjective survey measurements in the past. I think I'm running out of time, so I won't go out of these. But basically, in our future testing, we're looking at collecting more objective measures of workload, so heart rate variability and eye tracking data. If anyone has any suggestions of any objective measures that they have found useful to predict eye strain or fatigue with display use, would be very interested in that. Current test limitations, again, you could see in the pictures, you can see get some of the answers monocularly. There's ceiling and floor effects. And then they can be memorized. A lot of these tests are out there on the internet. All right, so just conclusion recommendations. We do see that none of the Air Force Vision testers correlated with our RVS performance, and don't recommend that they be used in the future, especially since they haven't been updated since World War II. And there's been a lot of better tests developed since then, whether or not they use our automated vision test battery or other tests. All right, thank you.